Problem 40 asks us to use Bayes' theorem to find the indicated probability. 2 shipments of components were received by a factory and stored in 2 separate bins. Shipment 1 has 2% of its contents defective, while shipment 2 has 5% of its contents defective. So when we're using Bayes' theorem, we kind of want to start off with a nice tree diagram to outline what's happening. So I have 2 shipments, shipment 1, and I also have shipment 2. It doesn't list any probabilities here, so we can assume that 50% come from shipment 1, 50% come from shipment 2. Probability of each is a half. Now, shipments can be defective or not defective. From either shipment, the component can be defective or the component can be non-defective. Sorry for my handwriting. So shipment 1, 2% of its contents are defective. That's 0.02 divided by 100. So just like the problem before, 98% are not defective. Shipment 2, 5% are defective. So 95% are non-defective. They've got to add to 1. They're complements of one another. So it's equally likely an employee will go to either bin. There we go. So that's where the half comes from. What is the probability that a defective component came from shipment 2? This is an interesting way. The probability that a defective component came from shipment 2. This is saying that the component is defective, right? The component is defective. What's the probability it's come from shipment 2? Put another way, what's the probability it comes from shipment 2, given that we know that this product is defective? If I know it's defective, what's the probability it came from here rather than from here? Okay, so this first branch is a product that is defective from shipment 1. Second branch, not defective from shipment 1. Defective from shipment 2. Not defective from shipment 2. Right, we can use Bayes' theorem intuitively. We don't have to necessarily use that formula here. But let's see. So here we go. So if we're just thinking about conditional probability, right? If we're just thinking about conditional probability, probability of E given F is the probability of E intersect F divided by the probability of F. Right? Bayes' theorem is just a special case of conditional probability. So let's try that here. This is equal to the probability that came from shipment 2 and it's defective divided by the probability that this product is defective. That's the same formula that we're using here, right? Probability comes from shipment 2 and it's defective over all of the defective products. What's the probability it comes from shipment 2 given that it's a defective product? Out of all the defective products, how many of them came from shipment 2? That's kind of what we're thinking. Out of all the defective products, how many came from shipment 2? What's the probability it came from shipment 2? So let's see that. So the numerator, shipment 2 and defective, that's right here. That's this branch. This is the probability it came from shipment 2 and it's defective. In my numerator, 0.5 times 0.05. Shipment 2 and defective, that branch. This is shipment 2 and defective. In my denominator, how can a product be defective? It can be defective from A or it can be defective from B. I need to show both of those. Defective from A or defective from B, from 2, sorry. That's Bayes' theorem. Shipment 2 and defective out of all of the defective products. And once we calculate this, we will have our solution. All right. So let's see. This is 0.025, right? So that's also 0.025. 0.025 divided by 0.035. And this is 0.714. That's our probability. That's what we're looking for right there.